Good morning, everyone. Here I am going to explain my project presentation. The top subject name is Instrumentation and Control of Energy System. The subject code is Engineering 9857. My topic is a single stage, single phase grid connected solar PV system. Our supervisor is Mohsin Jamil. This is the abstract of our topic. Solar panel and inverter connection to the grid and monitoring system make up the single stage phase grid connected solar PV system is the main part. So usually we use the solar PV panel for this the project, and the sunlight is captured by solar panel which transform the direct current electricity. This DC electricity is transformed into AC, the common type of electricity used in the homes, business by the inverter. When the solar system generates the more energy than is needed, the grid connection enable access the electricity sent back to the feedback. But after then, monitoring system offers the real-time data on the system operation and energy output. The single-stage, single-phase grid-connected solar PV system project, we introduce the renewable energy solutions that produce electricity using a solar photovoltaic technology. This system enables the effective integration of solar energy that make contribution to future and more sustainable energy source in the upcoming future. After then, the more abstract regulations promoting renewable energy sources have increased the solar energy consumption because of the electricity is the more increased due to the demands. Moreover, the electricity industry faces the numerical supply side changes like the outcome of coupling solar cells with the grids. The project recommends the single stage inverter with the maximum power points and one cycle control for grid connected PV system. The one cycle regulator method's output current adjustment is its core because of the connected inverter and grid without the needs the phase loop one cycle control based the system increasingly the different kind of application. Few sensors are needed for the implementation of the controller which consists of OCC and MPPT blocks. Then the introduction of our topic. The main components of the single stage, single phase grid connected solar PV system include solar panels, inverter, grid connection and monitoring system. Solar panels capture sunlight and convert into the direct electricity. The inverter converts the DC electricity into alternative currents, which is the standard form of electricity used in the homes and businesses. The grid connection allows excessive electricity to feed back into the grid, and the solar system generates more power than it's being consumed. After then, the monitoring system, the real-time information is the system performance and energy production. By connecting the existing electricity grid, the system efficient integration of solar panel can contribute the sustainable energy future. Solar energy consumption has increased as a result of regulations promoting renewable energy sources because of the electrical sector faces lots of challenges right now. The results, the connecting solar cell to grid, the single stage inverter with the maximum power point tracking and one cycle control is suggested in this project. The one more output current adjustment is the fundamental of the one cycle regulated method. After that, one cycle control based system are being used different type of applications because they can interface inverter with the lots of the solar grid, and whenever they needs they will the phase look up for the implementation of the core control consistency using the MPPT blocks and few sensors. The objectives of our project is the main goal of the project is to promote the broad use of the renewable energy, particularly solar PV system in domestic and small scale commercial applications. The project's goal is to motivate people and companies to switch to clean and sustainable energy sources by demonstrating the advantages and the solutions of their problems. Advantages and viability of the grid connected solar PV installations by switching to clean solar energy instead of conventional fossil fuel electricity generation. The project hopes to reduce greenhouse gas emission, the effect, and the other the problematic way. The single-stage, single-phase grid-connected solar PV system contributes to reducing climate change and the carbon footprint associated with the conventional energy sources by producing electricity from solar energy. The use of solar energy aims to advance energy independence at the individual and the social level. Solar PV system offer a decentralized energy system that decreases the reliance on centralized power generation. That's the importations of the fossil fuels. So basically, the topic is the relay on the using the solar PV panels and renewable energy sources. Single stage, single phase grid connected solar PV system operations with the following key contributions. Renewable energy generation, solar energy, which is the renewable and sustainable resource as we all know, is captured by the single stage, single phase grid connected solar PV system. That the system helps the lessen reliance on the fossil fuels, reduce the great greenhouse gas emissions and the carbon footprints, thus the converting the sunlight into the directly electricity. The grid supports and the energy independence. The system enables the sharing of generated electricity with the one place to another place by using the grid, integrating solar power into the electrical grid. Because of the transmission losses are decreased and the grid is supported during period of high demand. So most probably we can use the grid whenever we need the requirement of the electricity. The other contributions is the cost saving. By using the solar energy to produce electricity, the system helps to balance out the use of grid electricity. As a result, the system owners electricity bills are lower. They save lots of money and the system's lifeline. The system may even offer financially like feed in the tariff or net metering in areas with the favor condition and supportive policies, further enhancing saving. There are more objectives regarding the single stage, single phase grid connected solar PV system operation. Environmental benefits is when compared to conventional fossil fuel based electricity generation, the use of solar energy in the grid connected PV system significantly reduce greenhouse gas emission, even a carbon footprint. The system aids in reducing climate change and enhancing air quality by replacing electricity produced from non-renewable sources. So that's the main benefits for the environmental. We can not make more pollution for the environment by using this technology. After that, the economic growth and local job creation are facilitated by the installation, upkeep, and operation the grid-connected solar PV system, which supports the expansions of the renewable energy industry. As a result, local economy may be stimulated and the transitions to a clean energy economic may be aided. So this is the objective. After then the methodology. The research technique will involve doing a various technological methods such as the voltage sensor-less OCC-based inverter for PV system, MPPT implementation using P&O method. So that's the all the technique we can use in this project. The circuit follows solar PV panels create a DC electricity from sunlight by being wired in series or parallel. The solar panels power output is optimized using the MPPT maximum power points tracking charge control, which also charges the batteries. The DC-AC converter transforms the DC electricity produced by the solar panels into usable AC electricity that can be connected to the grid. So electricity grid and the solar PV system can extend electricity in the both directions. And thanks to the grid connection, so we can use this in the both direction. The appliances and the gadgets that use the electricity produced by the solar PV system that are the represented by the electric loads in the circuit diagram and actual installations. There could be the like fuse, circuit breaker, uh, grounding devices, and that the devices are assured safety and adherence to the electricity standard. Next, the electrical system adheres to regional electrical rules and safety regulations, including wiring, cables, and protective devices. Find and purchase reliable supplies of high quality solar panels, inverters, and other necessary parts. Because of the installation, the solar panels firmly on the roof of the ground as per the design requirements. So basically, we are following this the methodology when we are designing our project. Ensure that the solar panels and the other system components are properly wired and connected, so we can get a proper output. Install the inverter to transform the DC energy produced by solar panel into grid compatible AC energy. Utilize Utilize a grid connection point to connect the system to the electrical grid, and after then the verify the different kind of the all the voltage, frequency, power factor, as well as the other performance and quality parameters, so we can get accurate input and output, develop a plan for the system's operation and maintenance. And after then we can keep track record of the solar PV system, about the performance and the working activity. Install a monitoring system to evaluate the system performance in efficiency and maximize energy production, and gather the monitoring system. The After then we are discussing about the block diagram. So this is the block diagram for system. We use PV modules which is connected with the capacitor. The capacitor here is a work for the charging and saving the energy for the some time. And after then it's connected to the single phase inverter again, which is the help to convert energy one form to another form. So then the single phase inverter is connected with the L filter, where the filter is connected with the grid model. So this is the all interlinked with each other, and the pulse width modulation generator is directly connected to the single phase inverter. So you can mention here the control and reference generator, PLL, MPPT, maximum power point tracking, DQ trans, and the Q is an optional adjustment here, and this all the four combined together, control and reference generator, MPPT, PLL, DQ is all the processing and control in the block diagram. So this the basically the system runs in our as per the project. Thank you so much.
Okay, I'm Collins. Like my colleague Ashley said, the main aim of this project is to design and implement a simplified, effi- efficient, and cost-effective solar PV system that can convert sunlight into electrical energy and seamlessly integrating with the existing electrical power grid while contributing to environmental sustainability and promoting the use of renewable energy sources. Now, looking at the circuit diagram, uh, in the circuit diagram, we have our solar panels. The system begins with the solar panel, which consists of multiple PV modules that convert sunlight into direct current DC electricity. We also have our DC combiner box. The DC output from the solar panel is combined into a DC combiner bus. This bus typically includes circuit breakers or fuses to protect against overcurrent conditions. We also have our maximum power point tracker MPPT. The DC output from the combiner bus is then fed into a maximum power point tracker MPPT controller. The MPPT is a critical component that optimizes the solar panel's output by continuously adjusting the voltage and current to maximize power extraction from the panel under varying weather and the temperature conditions. Then we also have our DC to AC inverter. The MPPT output is connected to DC to AC inverter. The inverter's primary function is to convert the DC electricity from the solar panels into alternating current AC electricity, which is the type of electricity used in most household and the grid applications. We also have our grid connection. The AC output from the inverter is then connected to the utility grid through a grid connection point. It allows the solar system to export excess electricity to the grid when the solar panel produces more power than needed on site. Now, on this circuit, the circuit diagram effectively harnesses solar energy, converts it into usable electricity, and integrates it with the utility grid to provide clean and renewable power while allowing the efficient energy exchange with the grid when needed. We also have our simulations. Okay, we also have our simulation results, our MATLAB simulation result. This one is the PV voltage and power waveform. This is the simulation result. We also have our power waveform, solar PV inverter and the grid in kilowatts. We have our VIN voltage and current waveform. We also have our VI loop grid voltage and the current waveform. Now, in conclusion, a single stage, single phase grid connected solar PV system is a simplified and efficient design that converts solar energy into usable electricity and connects it to the grid. By utilizing solar panel and MPPT controller, a DC to AC converter and a grid type controller, this system optimizes solar power generation, ensures smooth integration with the grid, and allows the exchange of excess electricity with the utility companies. It enables users to harness clean and renewable energy while producing reliance on conventional fossil fuel-based electricity sources, promoting sustainable and environmental benefits. We also have our references. These are the references we reference our project. So thank you so much.